These relate to this box plot right here. Okay, now we're going to work on an example. With these following numbers, we'll find the minimum, quartile 1, median, quartile 3, and the maximum. First, we find the median, because that's the center of everything, literally. So now we know that there are 14 numbers. So when you divide that by 2, that equals 7. So you count 7 in. 1, 2, 3, 4, 5, 6, 7. From this way. 1, 2, 3, 4, 5, 6, 7. Which means 24 and 25. Now, since these both can't be the median, you actually have to add them up and divide them by 2. Which gives you this. Which gives you a median of 24.5. Okay, now move on to the next one, which is the quartile 1 and quartile 2. They are in between these numbers, so right in the middle. For this, the first 7, the one in the middle is ironically the number 7, which is the first quartile because it's in the lower range. Now this, sorry about the yellow, is the upper range. Same thing for here, 7. So 1, 2, 3, 4, 5, 6, 7. You count in until right in the middle, which comes up with 37, which essentially means quartile 1 is now, let's see, quartile 1 is now 7, and quartile 3 is now 37. There we go. Next, we have the IQR, which is the entire quartile range. So that is Q3 minus Q1. You take Q3, Q1, subtract, and you know the IQR is 30. Now you keep going, and to find the minimum and the maximum, to find the minimum, you have to use this equation, Q1 minus IQR. So that's 7 minus 30, which means the minimum is negative 23. And next we have the maximum, which is Q3 plus IQR, which is 37 plus 30, which means the maximum is 67. Now, I'm not going to actually bore you with an entire graph, but how the box plot, essentially you would number it, is as follows. You would have the line, you have your box. I'll explain the box in a bit. Okay, so there's your box. It's not the prettiest box, but it's a box. Now the median right here is 24.5. That's the median. Q1, Q3. So Q1 is 7. Q3 is 37. And the two sides would be negative 23 and 67. Now, the box were proportional. This would be more in this way, but this is just essential so that you understand what's going on. There's your plot. And that, my friends, is how you make a box plot by finding your 5-number summary.
I'm going to cover now is 7.2 standard deviation and mean of random variables. And this is the 3 basic concepts that you should be understanding. Concept number 1. The mean of a set of data points is the ordinary average, which basically, if you have like a small group of numbers, you just got the average of these 5 numbers. However, the random variable of x is also an average of possible values of x. But unlike regular mean, it can change. The random variable of x can change if not all outcomes are equally likely. Concept number 2. The mean and standard deviation of x. If you have this table, so you have x sub 1, p sub 1, right? X sub 2, and the probability of p sub 2, right? And so on. To find the mean of variable x, you find the mean by multiplying the event of what's going to happen, which is 3, like let's say this is a number, and the probability times the probability of this, plus event with the variable x times the probability of this, plus you keep adding until you reach to the end, which is the number of x sub k times the probability of p sub k. To find the standard deviation of random variable x, you take the square root of this entire thing, you take this value, subtract it from the mean, which you either is given or you have to find it through this formula. You square it and then times the probability, which is given here. Plus so on and so on. The last concept I want to talk about is the law of large numbers, which basically, as the number of observations increases, the actual mean will eventually be equal to the theoretical mean. So let's say you spend $4 on gas, and you calculate how many days you use the gas and find the average cost. Well, if you spend 2 days and you use it up, then the cost of driving your car is $20 a day. If you go for 4 days, then the average cost of driving your car is $10. If you drive your car for 8 days and you run out of gas, then the average cost will be $5. If it's for 10 days, then your cost will go down to $4 a day, and so on and so on and so on, until you reach an infinite number, or to a point where it eventually will cost you nothing based on the fuel of the tank. We can actually demonstrate this graph by the law of large numbers by using this graph. The blue line is the theoretical mean. And the data points are basically the means of the number of observations. As you can see by this line, as I draw the curve here, right? Notice how, like, as I approach bigger numbers, the mean starts to eventually approach the theoretical mean.
Okay.
So you see it starts to oscillate to the theoretical mean. As we approach, after we approach an infinite number of observations, given the pattern, it will eventually be equal to the theoretical.
And now I will be talking about discrete and continuous random variables. One method of assigning probabilities is by stating the probabilities of the individual outcomes, and then assigning probabilities to events by summing outcomes. For example, if you have 10 possibilities, you will be doing 0, 1 through 10 and assigning the outcomes, so on and so forth. Now, random variables with probabilities assigned this way are called discrete random variables, which have a countable number of possible values. The probability distribution of a discrete random variable lists the values and their probabilities. An example of this is if we were to give a value for x, which can be 0, 1, 2, 3, and 4 in this instance. Their probabilities would be 0 with 0.0625, 1 with 0.25, 2 with 0.37, 3 with 0.25, and 4 with 0.0625, as the following probability histogram shows. Now, something to remember. Every probability is a number between 0 and 1. Sum of all probabilities must equal 1. Continuous random variables. Suppose that we want to choose a number between 0 and 1 at random. Now, also assume that any number can work at all. Now, this will have an infinite number of outcomes. Why? Because 0.1, 0.01, and 0.001 are all numbers between 0 and 1. The continuous random variable x takes all values in an interval of numbers. Density curve describes the probability of this actually occurring. To follow, the probabilities of any event is under the density curve. All continuous probability distributions assign probability 0 to every individual outcome. Normal distributions are probability distributions.
Recording.
Okay. If I start casting like around like 4 minutes, because I'm gonna start editing out.
Okay. Well, you have to edit out 5 seconds.
Okay, that's right.